when you notice that they all share an x squared, I write out x squared times the remainder stuff. So like x to the 6th minus 4x to the 4th plus x squared minus 4. Now, it's within this set of parentheses. My bad, that should look like a 2. But it's within these parentheses that I'm going to do the factor by grouping. So when we factor by grouping, we're grouping 2 at a time within this other factor after I took out the x squared. Let's talk about what's the greatest common factor in the first group. So notice how they don't share a common factor. So I say, like if I want to see what they have in common, they have a 1 in common because they both can be multiplied by 1 or divided by 1. And we're left with x squared minus 4. So now I have a factor of x squared, and then this factor, x squared minus 4. And then what's left in the purple parentheses is x to the 4th plus 1. So if I broke it down one more step, we get x minus 2, x plus 2, and then the x squared, or x to the 4th plus 1. Last step is to figure out, well, what we have a product. We have 4 things being multiplied by each other that have to give me a 0. So you go through each factor and see what would make each one of these 0. In the first one, what would make x squared 0 is if it was 0 itself. In the next set of parentheses, x would have to be 2. Next set of parentheses, x would have to be negative 2. So I'm starting to rack up some answers. X is positive 2, x is negative 2. And then another solution would come from, well, I might need to set up a mini equation. Subtract 1 on both sides. Whoa. And then I have to take the 4th root of negative 1. So instead of the square root, I have to take the 4th root of negative 1. We haven't gotten to this step yet. Or this is what we're going to conquer more next semester. So what we're going to just start practicing writing today is just where we end up with. 4th root of negative 1, and we'll talk next semester of how we would calculate that. We'll leave this for next semester. I want to start today by going to notes. Let's go to notes. So right now we're going to piece it all together. And what we're going to deal with is the degree and shape. So first off, let's get some notes down. These 5 pieces are going to be on your test next Tuesday, where you're going to have to identify the degree and shape, the leading coefficient in the shape. You're going to have to state the end behavior, find the x-intercepts and the y-intercept, and graph or sketch your graph. And when we have the degree and the shape, the degree, if it's even, so if even degree, then we're looking like a parabola. If odd degree, then we're looking like what I call disco. If you imagine your arms. If your leading coefficient is negative, then you're going to have a reflection of some sort. You're either going to be both facing down, or your shape is going to change from going down to up to an up to down if your degree is odd. So as x approaches negative infinity, f of x is going to approach something. There will always be something in this spot. And then as x approaches positive infinity, f of x will be approaching something. X-intercepts are where we're going to have to use the strategy about factoring. X-intercept notation is where you have a number, comma, 0 as a point. Sometimes we may have more than one of those. y-intercept notation is when you have 0, comma, whatever your y-coordinate is. And notice what I'm using as the y-coordinate since we're dealing with this new notation now. And it's almost like we already know, instead of having f of x, it's whatever the function is when you plug in 0. We're getting used to this notation, well, or at least we're getting better with this notation. F of 0. Whatever the function spits out after you plug in 0. You're going to graph this right now. You're going to sketch it, by the way. So maybe I should have put sketch, because we're not going to have graph paper. We're just going to sketch this important stuff. We're going to find the degree and shape, leading coefficient and shape, the end behavior, the x-intercepts, and the y-intercept, according to the previous slide. You identify the degree, which will interpret the shape. You identify your leading coefficient, which may adjust the shape. Again, since it was a positive one, I'm just going to keep it the same. So with x-intercepts, we need some type of number, comma, 0. So we're going to plug a 0 in for this output. So if 0 equaled x cubed minus 8, we could either factor it or maybe try to go about it using the root method. So add 8 on both sides. And instead of taking the square root, I'm going to take the cubed root. So cubed root of both sides will undo. And then you've got to ask yourself, okay, cubed root of 8. No, we haven't gone into great detail about cubed roots yet, but I think you've got the knowledge where you can figure out what times itself 3 times gets you to 8. 2. This is more second semester, but I'm going to give you some easy ones that you should definitely know. I'm not going to give you something crazy like the 4th root of negative 1. We're just going to write down as, like from warm-up, we would just write down 4th root of negative 1. We don't know how to complete that yet. So this is the x-intercept, but that's not how I write it. I write it as 2, comma 0. So if I plug in a 0, I'm going to put the output of 0 as the y-coordinate. Plug in a 0. So f of 0 would be whatever 0 cubed minus 8 is. Negative 8. So my y-intercept would be 0, comma, negative 8. So working backwards, here's how we sketch. I can put 8 tick marks going down 1, 2, 3, 4, 5, 6, 7, 8. Put a point. There's my y-intercept. 2, 0 for my x-intercept. Put a point. And then between them, I'm going to try to make it look like an S shape. I got to get that onto this graph, and I've got to cross these points. So it's not going to look pretty, but do I fit my end behavior? Is my left arrow going down? Is my right arrow going up? And try to make it look like there's a little bump in there. Does that make sense? We're sketching, so it doesn't have to be perfect. It's just got to make sure it fits the end behavior. Do I have those intercepts graphed? That's how we sketch. It's rough. We're going to go through the same steps. Degree and shape, leading coefficient with the shape, and behavior, x-intercepts, y-intercepts. No longer up and up, but now it's flip. And then take the 4th root on both sides. Here's a special little thing, though. 2 times itself 4 times does get you 16. But so does negative 2. When you take an even root on both sides, it's where the plus or minus kind of comes into play. So in this case, not only can x be positive 2, but it's actually also negative 2. Because if you took -2 times -2 times -2 times -2, it does get you a positive 14. So we've got two x-intercepts, positive and -2, 0. And I can write my answer accordingly. I could either separate them or write it with a plus or minus. Y-intercept. Y-intercept, I'm going to plug a 0 in and then put its output as the y-coordinate. Zero 16 is the y-intercept. Okay, if I have more tick marks than 10, I'm not going to draw 16 tick marks. So I'm just going to put one way up at the top, and in my sketch I'm going to make sure I put a little 16 by it. There's my y-intercept. It can be that easy when we sketch. But notice how positive and -2 is less than 10, so I'm actually going to put the tick marks. And now I've got to make sure when I connect the dots or the points that I'm going to have a left arrow going down and a right arrow going down. So when I connect them, my arrows should be looking like this. And we connect them somehow, making sure we realize, okay, the shape is like a parabola. All right. My suggestion here, if you notice, okay, they all share an x and your leading coefficient is negative, don't just take out an x. Take out a negative x. That's going to be helpful when we deal with these polynomials. If you took out a negative x, all the signs will then change. Now we're dealing with a positive x to the fourth minus 2x squared plus 1. And then, yes, I agree with multiply add method. So we think what multiplies to 1 adds to -2, -1 and -1. And notice, wait a second, in these polynomials, we've got to figure out the first term is no longer x and x. So we have 3 x-intercepts. We have 0, 0, and I could put plus or minus 1, 0. Or notice how I don't have a constant here, and your y-intercept should always be your constant term. So I know my end behavior looks accordingly. Left arrow up, right arrow down. I start left, going through the points. Sometimes it's a ripple effect.